Okay, so welcome back. And before the Zoom session ended, we were doing the digitizing and it's done. It's okay. So we've created a certain feature, linear feature that represents a river, and we've actually given it a name. The layer name is a river. The name of the river is River One. Could have been called something else. Are you okay? All right. So could have been River and Cobra River, all the rivers, river names, the names that I'm thinking about. That's called the attribute. So when you see the word attribute, start thinking about that. I've just shown you. All right, so the editing is still ongoing. We have actually ended the whole digitize for this feature. And to save it, all we can either create more of it, more rivers, or we can just, anytime we want to create more rivers, we can. But for now, we're just going to end it. And it will ask you to save, you say yes. And if you want to start editing again, you just click it, select it again, and then you'll be in the position to actually continue from where you left off. Okay. All right. All right. So there we go. We can now create another layer. So you click it, switch it off. No changes have been made. We can actually change the symbology and let it look, maybe more colorful. I mean, depends on what you really want to do. Now it's looking more like a river. You know what I'm saying? Like, I mean, the color is wrong though. Rivers are supposed to be more of a blue color, So you just change it, apply, you can just be playing around with it. There's this shadow that we can also change the color of, if you don't really want that. So yeah, there's a whole lot you can do that, and that's not necessary. I mean, like, you can just choose this one and increase the width of it. So you can see the width is 0.6. You can apply this, and then we have something more cuter. Okay, now let's do what should we do now? I think that will be it. Let's do some roads. Is that okay? There are no roads here, but we are going to create our own fictitious roads. Okay, so let me show you how you do the points. I think it's the same principle. So please, you can try it in your own spare time. Create layer, add layer, vector layer, pick, instead of you picking a line, you pick a point. You save it somewhere. Are you okay? Layer, create layer, new shapefile layer. Okay, then you pick a point. Just do a point, pick a polygon to do a polygon. Okay, so you can do a polygon for the bounds very quickly. So we can call that the bounds, the boundaries. Just save, and then you can pick the recent layer that we use. It should be somewhere in here. Normally it keeps a reference to it. 2196 or something like that. Oh, where did it go? Not 32. TM. Do I have to always call for this? It also has 2619 or something. Was it 2691? Okay, yeah, I think so. So we look for 10. That'll be this one. Just say okay to that. You can always give a name to it. We are calling this one the bounds. Yes. So it's like a boundary. Toggle editing. So here you see this, it's actually expecting you to create a polygon, add polygon at the corner. All right.
910.
Thank you very much. I have it. So now I can create a polygon for the area of interest, or this could be imported if that's what you really want to do. ID1, say okay. Okay, so now that's it. You can just save. Yeah, you can change the opacity of this layer, change it totally, right? Or we can use a different type of layer altogether. I mean, it depends on what you want to do. Okay, apply. Okay, you can put it to the background. So you can actually move layers up and down. You can use this to shift them. All right. No, not that. I think it should have. It doesn't. So you can manually move it down. Okay, some software you have. So I've put it behind. So there's a boundary file for it. It's okay. So let's create. We've created a polygon. You can create point layer. You go to layer, create layer, new shape file. Then again, you call it I don't know, pine. So pine tree. So let's assume caption where the pine trees are. It's a project going on. You're interested in the pine trees. Put it on. Points. Choose points. Give it a name. You can probably put in height. Okay, talking about height. You need to go and download my app. I'm advertising my app here. Okay, so I'll be putting a decimal number for a real number for the height. Okay, so you can see that we can have more things in the table. All right, so let's look at the table for this one. So you right click and go for open attribute table. That's how you look at the table. Okay, that you are creating. All right, so let's look at the table for the river. Open attribute table. You right click it and you go for open attribute table. So you see we have one river one. Now we have to edit the point because we don't have any points for that. Let's assume these are pine locations. So pine one, the name for it, and call it spruce. I don't know. I'm just trying to put in something here. I can't put in I can't type a letter because I forced numbers to be there. 12.2. Okay, so you see, I've created my first point. I can end it there or I can add more to it. To the second one, I won't put anything. 6 point. So you can actually force it such that if only puts in values, it always puts in values. So this is the third one. Height 4.6. This is how you do it. So I've created 4 point trees. I save it by toggling editing. Save. It's now saved. So these files are being created behind the scene. So let's go and look at it. Let's go and look at them. So you see we have pine tree and each of them gives you about 5 files. You shouldn't delete one. The whole thing will be messed up. It will be corrupt. It won't work. So we back. This is what is happening in the background whilst we are doing all that we are doing here. And then we can change the symbology for our pine tree if you think it should be something. Maybe there are mine locations. You can put mine. You see, this one is looking more like a mine, isn't it? So there you go. 84. And so that is that. Nothing more to it. Okay, now we're going to create a fictitious. All of these are quite not quite fictitious, but at least they relate to something that exists on the ground. But I'm calling this one fictitious because I don't see any road in there. Okay, not so far. I see just boundary lines and maybe footpaths. So we're going to create a line layer that we are going to call roads, even though there are no roads there. So let's assume these are roads we intend to construct. I just want to use it to explain something to you. So we have, why don't you create a lake rather? So let's create a lake. Yeah. Polygon. And then we don't want to call it roads. We want to call it lake. It hasn't saved it yet. So you see, I can change it. So lake, save it. So the name of the lake. So name is always going to be one of the attributes you find in most GIS data, spatial databases. Toggle editing. Start sizing the lake of interest. So we are going to make it a bit bigger than, so we need to always go clockwise direction. Going to make it a bit bigger than it is. Just because you are doing a practical. When you're done, you just say, give it the ID, call it, sea lake. Nah, it's a bad one, but let's call it sea lake. So you can see that, we can just save it. Probably give it a color. We give it a color because probably want to show it someone. Okay, so blue is appropriate. Is that okay? So I see the river is kind of flowing into the lake, you know. So the lake we have originally is kind of it's expanded. It's an over. I don't know. There's an overflow or something like that, isn't it? What do you call that? It's flooded. Yeah. Okay. So there we go. We have these layers, and a few things that we can do is to actually do some kind of suitability analysis, you know, and it all starts with a raster analysis. And with most raster analysis, you need to actually have everything in raster. By the way, we have vector, raster. Are you okay? So in this, you know, layer panel, the layers you see in there, some are raster, some are vector. Okay. But then to be able to do a proper analysis of what is happening, then we need to turn the vector layers into raster layers. So we need to do what we call the rasterization. We need to rasterize. So you go to raster menu and you go to conversion and you go to rasterize. So rasterize is now going to give us something like a dialog box where we are going to specify the layer that we need to, the input layer for the rasterization. Is that okay? And then we need to give it a band value. So the idea of band is to band. Okay, it means you're actually writing it. So we are going to be putting values in the new raster. So we're going to create a grid of values, and we want to put in 1 for this lake layer. Are you okay? All right. So the fixed value to band will be 1. Then we're going to put georeference units. Georeference units means we've already associated a coordinate system with this. I hope we did. Anyway, let me go back and check. So let's come out of this and check the coordinate system for this layer. In fact, we didn't. Okay. So we've created a couple of layers in which we haven't used the 2690, and that is always going to be a serious problem. So we're going to come back to this rasterization process, okay, which doesn't work very well if we don't have the same coordinate reference system. So what we do is that we take the pine tree layer, which is in WGS84. It's not in the EPSG 26910. It's not in that one, which is actually some North American data. Because we are in America and we are working okay, as engineers over there. So we need to now do a rip projection. So rip projection is the reason why we learned map projection. So it's going to now take this, you know, spherical coordinate system and then convert it to what? A projected coordinate system using a formula. So this is how you do it. You go to right click and you go to export and you go to save features as, and then you are going to now name the file. So we give it the same name, then we add, and which layer are we on anyway? We're on pine tree. So let's give pine tree rip projects. We call it rip projects, repro. So that means we projected NAD. Okay, so we can even add NAD to it. So NAD is a new coordinate system. Save it. So here we go. We are getting a new layer from the existing layer, and all we need to do is say yes. But then before we say yes, before we say I do, we go and pick our NAD coordinate system, which is not appearing. I'm expecting it to appear in this list, but it never does. 26910, which is this one. And then I'm just going to say, okay. And that's the one that we want to use and not this one, this pine tree. So I'm going to remove it. Right click and remove layer, say okay. And then of course the symbology has changed because it's a totally different one, but obviously we love this symbology, so we're just going for it. All right, pine trees don't look like this, but obviously we just we fancy the symbol. Anybody can create this and put it in. So now this has a coordinate system of 26910. So the lake, we're going to do the same with the lake. Export the save features as. Then we're going to find where the lake is. Rename it as repro. NAD, not. So we just do save, and then yep, we choose it. We have to choose it. If we don't, we wouldn't know. 26910. There you go. Okay, so you have a new layer. Remove the old one, which is in WGS 84. It's on the spherical surface. Remove the layer. So now you have got obviously fancies the pink color, isn't it? So, but then we wanted something more bluish to show that there's some water in the area. All right, so we now have all our vector layers. Okay, we have do we have our row? We don't. All right, we did the pine. Let's do the road, but let's just stick with this one. Let's not do the road yet. Let's work with the river layer and then the lake layer. So we are just going to do the rasterization. We are back to rasterizing. Are you okay? So go for conversion, rasterize vector to layer, and it's gone straight for the lake. Okay, so that's not a problem. The bearing value should be 1. Press enter. Rasterize, open raster units, go for georeference units. This is what took us back to the projection. Is that okay? So now georeference units, then we have the width. Now the width, what is the resolution? Then again, everybody in this class, you don't have to understand anything in GIS. First, understand what resolution is. Don't even try to understand. Resolution is talking about the squares. Are you okay? In the image. Now remember that we're going to be working with the DEM. So the DEM here actually has a certain resolution, which you can find when you go to the information about it. You see that the pixel sizes are 30 by 30. Are you okay? So it's 30-meter resolution image, digital imagery that we have. 30-meter resolution digital imagery that we have. Okay, so there we go. So we are going to also make sure that our final rasterized lake layer is actually 30 meter by 30 meters. So we put in 30 meters. All right. And then we need to now do the output extent, which I would have loved to use the bounds as the extent, but for the sake of the software itself, I'll simply go for the lake itself. Okay, because I think there's probably a bug in there. When I did it earlier, it always throw an error. Okay, so now with this, we can just expect that the final raster will have a value of 1 wherever there's a leak. That's all. And then the rest will be 0. That's the idea of doing what we are doing. So hopefully, if all things work well, we should see a new layer which has some values in there. All right, so I can see rasterized layer with 1 in there in the panel. Okay, so if I take it up, okay, so we can see that it's actually giving me exactly the area where the lake is, but then the values are just right in there. Are you okay? All right, so it's been rasterized. So this is no longer a vector layer. It's actually, this is the raster version of this. What I really wanted to experiment with or try is to actually use a different extent. So let's try a different extent. If we get a result, that will be the ideal thing. That will be ideal thing, what we want, because the extent confuses the software sometimes. So let's use the bounds. And then let's see if it doesn't crash, then it means That is probably what we really wanted, but it still gives us that. It means it really has a little bit of a bug in there, but it's okay. Let's set this one. I think this one thing we need to do, not set, assign a specified no data value. Let's try that one. Like, very good. I think this is the ideal thing that we are looking for. Okay, this is it. Okay, so please, on your parameters, you need to do assign a specified no data value to output bands, not sets. Okay, not set. And then now we have our rasterized lake layer. Are you okay? All right. So let's actually tap on it and then see what the values are. So where I click now, the value is 0, and then the white areas are what? 1. So that is good. We are going to do the same thing. So we need this one, the rasterized layer. This is the one we need. So we save it as raster, lake raster. Okay, so we can just say okay, and then we can delete these ones which are not probably see, they're only at temporal layers. I'm removing all these temporal layers which we didn't even use. Okay, so we can do the same rasterization for the river itself. Okay, now the idea is to use a raster calculator and then to combine the rasters together. All right, so conversion rasterize vector to raster, and this time we are going to pick the river which we digitized, which is in vector form, same values that were used, output raster georeferenced units. Resolution is 30 by 30, and we know why. Resolution determines how sharp the images look. The output extent is actually a set of coordinates. I don't think you see my dialog box. Do you see my dialog box? Can anybody confirm that you see my dialog box? The one I'm working in right now. I doubt if you see it because I watched the video. I didn't see the dialog box. I'm working in the dialog box right now. Can you see it or not?
Yeah, yeah.
You can see it.
I can
Okay.
see.
Okay, that's fine. All right, so the output, we do it from a layer, we do it from a bounce, and then we do not set for no data, assign a specified no data value to output bands. Okay, so the output band will now have, when there's no data, we'll just do not set. Okay, great. And then let's go back. Let's go down and see if there's something we haven't done. All things being equal, we should see something like what we just saw, but this time we'll have the lines, rather we have the river, so you can see that that's it. It's looking just like the other one, except that this time around we are having the river. Are you okay? So this is the whole idea. We are going to do a raster analysis, and we are taking things, we are doing a conversion. This is called rasterization. We are rasterizing. You hardly do vectorization. Vectorization can be done if you want to extract, building outlines, things like that, which is always an interesting topic. People do PhD just to be able to do that. They develop all sort of algorithms. It's not easy to do the extraction. You may not get it right. All right. So, but then vector to raster is, I think it's very practical. It can always be done. So we can name this one, we can save it as, export it, put it somewhere, call it raster. So my desktop. So where did I actually save the lake? Okay, let me check. I want to check where this one went to. By putting your mouse on, I think you get to know, or you just go to source, information, where you save this file should be available somewhere in here. Okay, so I think that information is not available, but anyway, that's a shame. But naturally we want to just save it somewhere. Let's export it anyway. Later we'll find out where it went. Okay, so you see the lake is here. So it went to documents. It's very important to know where your files are. Go to river. So this is a river raster, and then it's going to NAT 83. So all our layers should be on the same layer. So now it's saved on the computer. We are removing the temporary file rasterized. So we removed it. So now we have the DM, we have the lake as a raster, we have the raster as, what do you call it, the river as a raster layer. All right, so the work of this thing is done. Somehow it is done. All right. Okay, so one of the things that you want to do is to actually combine it. Are you okay? Combine all this into two, because they all talk about where there's water. Are you okay? And we want to have it together. So we have to find a way to actually combine it. So we are going to make use of a tool called the raster calculator. All right, so I'm just going to show you a typical example of the raster calculator in use. All right, so we going to go to a tutorial, which is very good. So I'll share this link with you. This one is a multi-criteria overlay, which I'm actually putting in on your WhatsApp page right now. You can access it and look at it. All right, so there we go. After the rasterization, before I even use that, I think one thing that was actually done in this tutorial was to create a proximity analysis. So proximity analysis kind of try to show you which areas are a certain distance, are you okay, from the points of interest. So here, in this layer, we are showing that these areas contain water in the one that we did. Are you okay? So now, can we actually, show how close we are to the water bodies? That is what the proximity is about. Proximity is how close you are. Are you okay? It's proximity. All right. So we just select the layer of interest, and then we set a certain maximum distance to be used for the proximity. Are you okay? Then it generates a new layer. All right, but a few things need to be, they have the no data value will be not set, 0 georeference coordinates. So let's try it. Let's go back to our QGIS and then do it for, what's it, let me see whether he did a combination before or not. He's not done the combination yet, has he? Okay, he did a combination, so we can do that combination first. Okay, guys, I think I kind of swapped it. Let's do the combination of the layers, which is done by the calculator. This is a calculator. So the one layer, the layer names always have this at 1 at the end. So we're just going to add one layer to the other. Simple as that. And then we are done. Okay. All right. So yeah, we're going to launch the raster layer and then give an output and then see how the two combine. All right, great. What am I sharing now? I'm still sharing my QGIS. Okay, and I thought I was back at the, so let me just show you where it is. We go to the raster, we see raster calculator, but go here, go to your processing toolbox and type raster calculator. Calculator. Hey, where are you? Oh, let's type calculator. Where's it going? When you're looking for things, that's when they disappear, isn't it? Fill calculator. Okay, we want this one, raster. I think I'm not spelling raster. Wow, how was I spelling the raster? I was spelling raster as raster. Raster calculator. Calculator. Okay, it just doesn't want to come up, but it's hiding here. Calculate. What was I not doing right? Okay, anyway, so just double click on that. Then it picks, so it's picked the river raster layer. And then we want to just give a proximity, and in the proximity analysis, let's go back. We'll come back to it. Let's go back to the raster layer and measure, use a measure tool up here in the tools. If you don't have it, you can just fidget with it a bit, tweak it around, you find it. Let's say a distance of about from here to here. Okay, so we want it to look like, okay, if you are about this distance from the river, we are interested. Are you okay? So in our analysis, we know that things that are a certain distance from the river has problems. Are you okay? So, or we need to factor in it. In a hydrologic analysis, you may be interested in a certain distance away from the river. Are you okay? Fine. It depends on what you want to do. For now, let's have an open mind. And this distance is about 1,002. So let's make it 1,002. Yes. So 1,002 will be our maximum distance. So raster calculator, where are you? Bring it back up for the river. Okay. And then we are going to look for the maximum distance. Wow, I think this one has more parameters than we think, huh? Okay. Why don't you just use our normal raster calculator? No. What am I doing? Okay, I'm doing what you call it. I'm trying to add 2 layers and I'm picking the most complicated calculator. Okay. All right, that's funny. I just want to add the lake raster and then the river raster. I'm quite hungry, guys. I think that could also correspond to be the reason. Okay, I'm quite hungry. I haven't had breakfast. Good breakfast. I had breakfast, but not a good one. So this is how it works. They are operators, mathematical operators. So we are doing what we call raster algebra. If you know algebra is x plus y. Are you okay? A plus B is equal to 2b. You know, I really used to love it a lot when I was a kid. You know, so we are going to have the first one. Okay, just double click it and appears in the raster calculator expression down here. Then we click on plus. That means I want to add this one. You click the second one, so river plus lake. Remember that they contain zeros and ones. So wherever there's one, there's water. Wherever there's 0, there's no water. Let's remember that. Okay, so the output, we're going to put it in our folder, which we are calling, okay, I put some stuff here, so let's put it here. Let's call it water. So whether river or no river, water. Okay, so everything's looking okay. The projection is fine. Because we are using the same projection system for our layers, we don't have a problem. It's going with it. Any new layer is created in that layer, that projection. All right, so now I'm going to simply say, okay, get this out of my way. Excuse me. So all things being equal, we can now switch off the raster and the lake layer, and now we have one layer containing all the river bodies. Okay. All right, so with this, we can now see a few things that we can do, possibilities. Okay, we can actually do the proximity raster. So raster, now we need a proximity to proximity raster distance, proximity. The maximum distance we said is 1,200. So why is it giving us that? 200. So in the units that we are actually, so let's check a few things. The distance units is pixels. Okay. And then what again? We don't use pixels. Let's use georeference coordinates for that. Georeference coordinates. That means you are using the coordinates for the same, you know, the layers that we are using, we've actually loaded. That becomes a georeference coordinate. So 5, we use 1,200. No data value to use for the destination should be no data value should be not set. So you just click this button on this and it should be not set for you. You have 10 minutes. When it's ended and I'm done, you don't come again. Okay. All right. So I think that should be just it. You can just say okay and then see what happens. You want to generate surface. Okay, so that's interesting. So now we are having an interesting result showing up. Proximity, in terms of proximity. Let's pick the eye tool and see whether these values are actually varying that much. But I think it's kind of reverted. It's inverted somehow. Let me see. So we are getting, yeah, some values in here. 618. Okay, so which layer is selected? Let's see. 330. Okay, so these huge values are actually no data values. They have not been set. Are you okay? And these are the actual. Okay, so we haven't zeros. Okay, I think I quite get it. Values. So the idea is to just have a certain. It's not really what the ideal way that we want to see it work, because the proximity shouldn't be the same. Are you okay? So maybe one or two things in the parameters need to be set. Okay. I'll show you an ideal one. Let me just show you the ideal one, what you're supposed to have. Maybe just our parameters. If we go to this one, in this particular case, you can see that we don't have the same value. It seems to fade out from the feature of interest. I think maybe something, if something is there's an inversion of exactly how we want it done. And so value to apply to all cells that are within the maximum. Let me see. Value, unless maybe we put in some wrong value somewhere. All right, so let's go for proximity raster again. So we still have, okay, let's pick our water, and then maximum distance we choose 1200, and to reference units I need to apply to all pieces that are within that. Okay, so no sets. We want to just do it again and see if we get something more interesting. Okay, all things being equal. All right, so I think the basic things have been set. So as to why we have it reversed is quite it's always something that you press that does some weird stuff for you. All right, but then we're really like on track, so I think we get same thing again. It's not the ideal thing that you want to have. Okay, all right, so let's look at our water layer and see, does it make sense? Okay, the water layer has 0 everywhere and it has 1 where we have water. Okay, so going back to QGIS. Okay, so this is what we want. We have 1. Okay, so I just show you the tutorial again. I'll take you back to the tutorial so that we double check and see if there's something that we have missed in this tutorial. And I think we haven't really missed anything per se, have we? Oh, okay. I think this is probably where this is what we haven't done. Okay. So yeah, what he did is that assigning the value of 1 that marks the expression and 0 where it doesn't. Okay, so what were we trying to do with that? Okay. All right. Now there's a problem. Let's read. This is where the issue is. The resulting merge with raster will have pixel values for all areas of water, but you will notice that there are some regions where there was both water polygon and the water polyline. Okay, those areas will have pixels value 2. Which is not correct. We can fix this simple expression. Okay, I don't know if this expression will work, but we will try it and see. So let's use the raster calculator and try and see if it works. Yeah, so we just remove it because our proximity map is not looking very good the way we wanted it. Okay, let's go back and see. So the raster calculator, we want to check if, so the expression is that we just put this input greater than 0, and just I think that's just what we do, greater than 0, and then we set an output layer. Yeah, okay, elements select. Okay, great. So let's do this, greater than 0. Expression is valid. Okay, we have an output. So let's call this water 2. So water 2. Okay, so this is something that we can run and see what happens. I don't know what the effect will be, but I think it will almost be the same, you know. But then if you put it into this, then we expect to have, you know, something looking more like the proximity, unless maybe our distance is not right. So let's check out the distance again. It's in meters. So this is 2,930. So this is the georeference. Because if the distance is wrong, of course, things will look very, very off. All right. Okay, so close it. It's looking okay to me. So we can do proximity, pick up that. We have 2 minutes. Okay. I don't know what it means. 2 minutes. What can we do with it? I think probably we can just keep fidgeting with it to see what happens. Excuse me. No data value to use, said not set. Okay, so let's revisit those values. Let's see. All right, not set. Okay, so we still get, this is weird, so this can be fixed. So when I'll look at it, why it does that, and then I'll post to you, I'll let you know why it does that. There's always a reason why it doesn't do. Could also be you are just hungry and you need to get some food to eat. So let's end it here, guys. I know most of you have not been because of your connection, but it doesn't matter. This is to be continued. This is, well, this is to be continued. I'll update you. I'll update you on the other aspects of this. We are heading towards doing a suitability, a multi-criteria analysis. So I'll send the rest to you in the next, meeting. I'll send you the video. Are you okay? How the final thing is supposed to work. So do take care, and then God bless you. Enjoy the weekend. Bye bye.